Thanks everybody for coming out. Couple logistics things before we get started. So PAC is no longer sponsoring the pizza, so we have to figure out what we're going to do for lunch. We can brown bag it if people choose. We can go a different route. We can just have that discussion in the general channel, so we can figure out what we're going to do from there on out.
Is there a particular reason they discontinued that?
So IT is no longer on the PAC contract as a whole.
Okay.
So it's hard to justify an IT funding an IT dev group every 2 weeks. We were already one of their more frequent meetings that they had. So I had to lobby really hard to say, hey, this is valuable. This is valuable. But now that the argument is kind of hard to do, even harder. So we just have to figure that out, see what we want to do. We could go mostly remote, but I think that kind of loses some of the feel of the group. I kind of like us getting together every so often, but we'll figure it out. Let's have that discussion in the channel. Christine's going to present today. I might do a little bit after she's done, depending on how long she takes. We have an external group that's coming. So one of the members of our group set that up for us. So I think they're coming at end of January. I think it's a little off our normal rotation. It's like a different Friday. So they're coming. They're a vendor, but I asked them to not be vendory. Don't come to us and sell us stuff. So they've agreed to that. So hopefully they stick by that. I think it's related to network security, which I thought might be interesting. So we'll see. I'm going to sign myself up for talks. When we first started doing this, I did like 80 or 90% of the talks just to kind of get the group going. I think we're kind of back to that stage again. So I'm gonna say officially now, I'm gonna do a talk on Kubernetes, which I have done that much Kubernetes, but I want to. So I'm just gonna sign up for it, and we're gonna do it. Damon, I'm gonna put him out there too. Damon's gonna help me because he's doing some Kubernetes at home as well. So we'll figure we'll do the intro to Kubernetes, and then we'll invite people that know Kubernetes, and they can just correct us every time we say something wrong. So, or at least we'll have the topic, and then we'll figure out some other topics. Ezra moved all our topics over to Teams, so you can see them now in the Teams area. So if you like a topic, want a topic, just add it there and we'll work it. All right, with that, and I think that's all I had. So Christine, take it away.
Hello. Okay, we won't have horrible feedback here. So I'm actually going to be giving this talk to the Justice, which is the archive I work for, in a few weeks. So I thought, well, why waste a perfectly good presentation and only give it once? So you guys are kind of my dry run for this. So let me share my screen. Somehow. Oh, there we go.
You gotta love that Teams UI.
Okay, do you see my screen? I'm not sure.
Yep, we can see it.
Okay, great. I'm also getting some kind of pop-up about security, and I was worried this wasn't going to work. Okay, so okay, still see it? Looks like it. Okay, great. So this is about parallel structure. So it's not actually a technical talk. It's a talk about English, something we all have to deal with on a regular basis. And the inspiration for this talk was many, many years of looking at people's posters and presentations that had this one like critical kind of thing and they were doing it wrong. I mean, I feel like a good 50% of presentations are bulleted lists, right? Which is good. It's good to have bulleted lists. But if you don't do them correctly, they can be more difficult to read. So the final push for this was actually this AGU last December. We had like a poster party where people could go and like put up their draft posters and people could sort of give them suggestions on it. And basically every single poster I looked at had this issue to a larger or lesser extent. So we're going to be talking about parallel structure, which is something that I sort of learned formally in a technical writing class I took when I was an undergraduate that turned out to be much more useful than I thought it would be when I took the class. Okay, so what is parallel structure? Unfortunately, there's going to be a lot of words on these slides because we're talking about English. So it's a little hard to do that without words. Okay, so parallel structure, I call it parallel construction, is a method of formatting written elements so they correspond to each other structurally. Parallel structure can be applied to any closely related elements. However, it is most often applied to headings, bulleted lists, numbered lists, lists and sentences, and tightly coupled phrases or sentences. So, you know, it happens in sentences as well, but we're going to focus on the fact that we do it a lot in lists and bullets. So what does this mean? Basically, you don't want to mix and match sentence structures. Every element on your list needs to be the same kind of thing. So it needs to be, each element needs to start with the same part of speech. If one thing is a sentence, they all need to be sentences. They all need to be the same sort of sentences. If they're phrases, they need to be the same sort of phrases. And why should you care about this? It really makes your writing easier to read and understand. Basically, 90% of this talk is going to be examples, and I hope that by the end of this, I'm going to have convinced you that if you take some time to do this for things that you're going to be handing out to other people, it makes a difference. It is, I think, one of those things that's relatively easy to get right. Like once someone points it out to you, I think it's pretty obvious when you've done it correctly versus when you've not done it correctly. You know, I don't know how to diagram a sentence to save my life. Like, they stopped teaching grammar when I was a kid. I don't know, like my parents know far more about grammar than I do. So like, I feel like you can get this right even if you learned fairly minimal grammar in school. I think it actually helps you organize your thoughts logically, because sometimes when you take a list that you know isn't parallel and you try to make it parallel, it becomes obvious that some of the things you've put in your list shouldn't be in the list because they're not like the rest of the stuff. And so I think it actually helps there as well. It makes your writing more professional. I have never seen something written by like a professional writer who's writing about technical stuff, like technical journalists. I have never seen them do this wrong. Okay, so like this is something that professional writers do, and you don't even notice it because their writing is just nice and it's easy to read because they do this, among other things. It's also often required to make your writing grammatically correct. So particularly if this is in a sentence and you don't do it, then it's grammatically incorrect. If you, rather than writing a sentence, make it a bulleted list, you can make an argument about whether or not it's grammatically correct, but like really it works well. And the reason why you want to do this is because when your brain goes through a list, it's much easier to process that list if all the things are the same. If they're different, then every element of the list, your brain has to try and kind of like figure out how it fits with everything else and how to, how to organize things. So basically, if you use parallel construction, then the brain, it's very easy for your brain to kind of just put everything together. Okay, so examples. Like I said, this is going to be like 90% examples. And we're going to start with examples I made up. And then we're going to go to some examples I found in the wild. So we're not going to be, I'm not trying to be like super judgy here. I'm just trying to show that like in things that NASA publishes on the web, there are problems associated with parallel construction. I also want to say that like I'm not perfect at this. I catch myself doing it wrong. And certainly like when I'm just writing my own personal notes, a lot of times I don't bother to go back and like make this perfect because it's just my personal notes. But for things where like I'm giving it to somebody else or writing a proposal or a poster or something, then I do make an effort to make this correct. All right. So you're going to notice that a lot of these are data archive related because I'm giving this talk there in a few weeks. So here we have, at the JES disk, our data is always consistent, curated, citable, reliability. Okay. I want you to think about this and figure out, like, there's something on here that is not right. Is it obvious what is not right?
Reliability.
All right, yes. So the first three things here are adjectives, and the last thing is a noun. So you can, if you read this list, you kind of know what I'm talking about, but that reliability is not right. So all you have to do is change it to reliable, and suddenly everything's an adjective. It's consistent, curated, citable, reliable. And this is much easier to read. Okay, so this is a very simple example, but there are a lot of bullets that are like this where it's just one word. So if it's just one word, make sure they're all the same kind of word. Okay. Henry is having trouble with a data file. He downloaded blah-de-blah.nc, opened the file in Panoply, looked at the metadata, which looked fine. Clicking create plot does nothing. Okay. So what's not working here?
I don't know.
All right, so like I said, this one's a little more complicated. I want you to notice that the first three things here are in the past tense, okay? Start with the past tense. The last one, clicking, is actually a gerund, so it's actually a noun, if you remember vaguely from like elementary school English, right? Clicking create plot does nothing. That's actually an entire sentence. It's not a phrase. The rest of them are phrases. You can't just write open the file in Panoply because there's no noun in there. So the problem here is clicking create plot does nothing. Everything else started with the past tense, it was a phrase, and the last one is a sentence, and it starts with a gerund. So what you want to do is say that he clicked create plot, which does nothing. Okay? So very simple change. Downloaded blah, 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 opened the file, looked at the metadata, clicked create plot. Now we have consistency. Yeah?
Why can't we move that bullet point between the first sentence and the he?
Move that bullet point.
Or change it back to clicking. Henry is having trouble with the data file. Clicking create plot does nothing.
Yeah, you can do that too. You can do that too. Yep. If you don't want it to be part of the list of things, then yep, that's a perfect correction as well. Yep. Okay, next one. We find, you're going to see a lot of this in papers, right? We find that our new algorithm produced results that are consistent with the algorithm published in Jones et al. Is 3x faster than the algorithm in Jones et al. Compatibility with existing libraries makes algorithm code easy to use.
Yeah, last one was weird.
Compatibility.
Yep. So I promise not all of them are going to be the last one.
I was about to just default to the last one.
Right. Sorry. Okay, so again, the first two here are phrases, and the last one is a sentence. So it's sort of like a comment on the other things. So if you want to change that, you can say, we find that our new algorithm is easy to use because it is compatible with existing libraries. Or, whatever. You can, there are multiple ways that you could change this. Okay. Here we go. Like I said, this is all examples. Sign up for the insider track at blah blah. You will need to verify your email address. If you have trouble or are denied, you can contact me directly at blah 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 for help. Start getting the insider track weekly update.
The last one.
Still feel like the last
Kind
one.
of action after you finished first three.
Or it's like a header for the first three.
Okay.
The first one too. I think the first and last are different.
First,
Exactly. So the first and the last one, these are imperative sentences, okay? So you're telling someone to do something. I think imperative. Okay, I apologize in advance if I don't get the grammar names completely correct because it's been a long time, but I believe that that's what it's called. The first and the last ones are imperative, right? It's commands telling you to do something. The second one is not an imperative, right? And the third one is, it doesn't even describe a step. It's just saying, like, if you have trouble, you can do this, but it's not a, like, necessarily a step in the process that you're describing. So I would change it to sign up for the insider track, wait for a verification email and follow the directions if you run into trouble or are denied, blah, 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 blah. 3, start getting the insider track weekly update. So now these are all 3 imperative. And the thing is, like, you could make changes in other ways. I'm just saying this is one way to do it. And this is an example of where sometimes when you, like, you cannot make 3 into an imperative. Like, it just doesn't make any sense. So this is an example of sometimes where going through this process will make you realize that some of the things in your list should not be in your list because they're not like the other ones. Okay. Ingest data flow. We search against CMR for data. We download data. We transform the data into Parquet files. The data is uploaded to S3. Because the data is in S3, Athena sees it and we can start to run calculations against it. So. This one is a little bit harder because they are all genuinely sentences. So I would go with like, these are not like the same kind of sentences.
The fourth one is passive.
It is, exactly. Yes, the fourth one is the passive voice. So the way I would look at this is definitely the fourth one is the problem because it's the passive voice and the other ones are active voice. Also, the other 3 start with we, right? So you've got we, da 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 da, we, da 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 da, we, you know. So the brain is kind of primed for we to be the subject of the sentence. The third one is then this passive voice, like, okay, how is the data uploaded to S3? And then the last one is, again, the active voice. So Athena is the thing doing something, but it starts with a clause. So it's kind of non-ideal. You would prefer to have all of them not just be sentences, but be the same structure. So what you could do is change it to, we search against CMR for data, we download data, we transform the data into Parquet, we store the Parquet files in S3. Athena sees the data because it is in S3 and we can start to run calculations against it. But I feel like at this point it becomes kind of obvious that this last one is doesn't really belong on the list because it's not something we're doing. It's something that happens as a result of what we've done. So I'm going to make the argument that actually it would be better if you just pulled that out because it's not really part of the ingest data flow in terms of like things we are doing where we are the actor. Okay, so this is going to be a very quick presentation. We're like, we only have a few more to go. Okay, so how do I find problems? All of the elements of a list should have the same verb tense. So if they have different verb tense, you know something's wrong here. All of them should be sentences or fragments. So you can either do all fragments or all sentences, but you can't do a mixture of fragments and sentences. If the list elements are fragments, so they're not full sentences, you should be able to make each element into a sentence with the same starting sentence fragment. So here I have an example, 3 elements: run calculations, create graphs, writing papers. For the first 2, you can say Jane likes to run calculations. Jane likes to create graphs. Jane likes to writing papers is not a sentence. So if you have fragments, a very easy trick is can you make each of these sentences with the same few words at the beginning? If you can't, then they're not the same kind of thing. Okay? if all of the elements are sentences, then they should be the same kind of sentence. So all imperative sentences telling people to do something, all sentences where Jane is the actor or whatever, all active voice sentences, etc. So you want to get as much similarity between the bullet points as you can. All right, we're going to go to some examples in the wild. So some of these are absolutely fine, and some of them have some issues. So I tried to even them out, and some of them are from the same page. But, you know, some are fine and some have issues. So here's and these are from NASA websites. So I apologize in advance to the folks who wrote. It's just, you know, I just wanted to point out that this is not, like, this is an issue that I see all the time, all over the place, including on NASA stuff. Okay. So let's take a look at this one. Anyone want to take a stab at this one? And remember, I said some of these are fine.
It seems basically fine, but the first one has 2 sentences.
Yes, so you could make an argument that the first one has 2 sentences. You could make an argument that like 3 of these start with the word be and the other 2 don't. I'm going to make the personally. I think this one's fine personally. You know, they're all. You can create a sentence with what they started the sentence with, individual steps should, and it works with all of these bullet points. Individual steps should be domain agnostic. So I think this one's fine. Okay. Next one, from the same page.
Middle one needs help.
I agree. I agree that this one needs help. So the first one is not an imperative sentence. It says we should have traceability. So it's saying like, this is the kind of thing we want. The second one is imperative. It says use immutable representations of data. So everyone gets what imperative is, right? It's where the you is the implied subject and we're telling someone to do something, right? And then the last one is not imperative. So we have that kind of mixture of sentences, some of which are imperative and some of which are not. So I argue that actually that first thing is just like a statement of what you want as a result of provenance. And then you can say, you know, use immutable representations of data. And then the bit about the versioning, you want people to use versioning. So you just say version all software. This is how I would make the change. Other people could make the change in other ways. It's just, this is an example of one way you might fix this. Fair? Okay. So this is another one. This is actually from the Justice. So this is on one of our help pages. Anyone want to be brave and say anything about this?
It's fine.
Yeah, I'm going to agree. I think it's fine as well. Right? We have a list of things. They're all imperative, telling you what to do. I think it's fine. And like, as you read this, I feel like it's obvious what you need to do, right? Because it tells you, you do this, you do this, you do this, you do this, right? Very obvious, easy to read, good to go. Okay, here we go. I know these are really dry examples. But this is the kind of stuff that we do all the time, right? Anyone want to take a stab at this one? No?
I guess I'm wondering if they really needed to have the indented bullet.
I would tend to agree with you there. Yeah, I agree. Also, number 4 is like oddly is different font size from the other one, but I assume that's kind of just a format issue. But yeah, I agree that I don't know why your thing's there. So here's my analysis of it. Okay, so the first one here starts with a clause. The second one, right? So they're imperative sentences, right? So the first one is imperative, but it starts with a clause. The second one and the last one, or these other ones, including the bulleted, the indented one, have no clause. They're imperative, but they don't start with a clause. So it's you kind of want to either start them all with the same clause or not have a clause at the beginning. But then you have this other thing. 3 is not actually a step, right? It's not actually telling you to do something. It's telling you about this step where you're going to click on something. So it's not a step. It's not an imperative. If you tried to make it an imperative, you wouldn't be able to because it's not telling you to do anything. So this is how I would do it. I would say go to blah, 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 blah after registering with Earth data. So that moves the clause to the end rather than starting with a clause. Search for blah, 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 blah. You should see a data access box with multiple access options. So this was that number 3 part where they're telling you that there are multiple access options. We will use the HTTP service for this how-to. 3, click on Online Archive. This was that indented bullet. 4, click on the 2010 folder, blah, 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 blah. 5, run the following Python cells. So now all of them are imperative. You can still get that information in there that like, hey, there are other ways to download data. In this how-to, we're just going to pick one of them. And now it's kind of obvious what actions you need to take, I think.
The first 2 non-numbered sentences are kind of true.
Right. So there's the okay, so my husband, who's part of the group, is here too. And he pointed out, I mean, like in the room with me, he pointed out that the first 2 sentences you could work on as well. But at least now the list is a little better. Okay. So I have some additional resources here. You can do a Google search for parallel construction, and every English department at every college that teaches English will have something on this subject. So it's all over the web. There are lots of results. All right, so that's the end. I told you it was going to be short. But hopefully, like if you kind of like go over some of these examples, hopefully it becomes a little, it's something just to be aware of. I think once you're aware of it, it's relatively easy to go in there and fix things. Anything from anyone?
Oh.
Okay.
Sorry, we dropped out for a second. Sorry.
Okay, sorry about that. Yeah. So, yeah. All I was saying is that I think once you become aware of this, that this is something you should look for when you have bulleted lists or lists of any kind. Bulleted lists, numbered lists, or just lists in your sentence. Just something to keep in mind, especially because we write these all the time, all over the place. Any questions?
Oh, cool. This is definitely one I have to rewatch again. To make sure. I don't English well.
Like that's not true. And actually, so
I lean into it.
I see this less with people who are native English speakers because I think we intuitively do this, but sometimes your intuition doesn't get you 100% there. So it's useful to just point out that this is one of those things you need to be a little careful about. For folks who are not native English speakers, on the one hand, I feel like they know grammar better than we do about the English language, at least in terms of parts of speech and things. But, you know, if you're having, if when you write in English you have subject verb agreement issues, then, you know, you might have some trouble with this just because, you know, you're not getting the correct form of the verb anyway. But you have a leg up because you know grammar better than we do.
Okay.
All right.
I have a question for the group. Oh, does anyone else have any questions before I ask my questions? All right, so I have a question.
I'm chair.
So there was a discussion we were having, and I was looking through my old presentations. It's like, which one can I recycle really quickly without a lot of prep? And there was a discussion that we were having in the channel a little while ago about testing. So I had a presentation I did a little while ago about automated testing that we can run through and just use it as a baseline for a discussion. If you guys are open to that, or if you want to wrap up early, it's totally up to you all, not you guys. All right, I'll take your silences. Go ahead, Andre, do it. Let me see if I can pull it up here. I have it on my other machine, so drive. And yeah, there it is. All right, I'm going to share my screen. And feel free to stop me or yell out, "That's wrong." That's completely fine. Present dish tech. I'm going to do. Where is my hiding? There we go. All right. Can you guys see that online?
Looks good.
All right. So automated testing overview and lessons learned. These lessons learned were, I think, learned 2 years ago. So I may have learned new lessons since then. All right. So what is automated testing? Anyone want to take a stab at that? Not everyone knows what that is. No one wants to take a stab at it. All right. So simply put, it's code that you write that tests or exercises or verifies other code that you've also written. You should not write tests to verify code that you have not written, because, well, usually you don't want to do that.
Well, that's the whole like test first principle, though, right? Like, I'm sure you've heard this, right? Test first coding.
Yeah, we're gonna get into that. So we're TDD and stuff like that, or it's a little bit later on in the slides. But we'll talk a little bit about that. There's a couple of different versions of that. Some that people do that they don't realize they do, which is I thought was pretty funny when I heard this. So how many of us are actually writing automated tests a day?
Yep.
Yep, that many, huh? So yeah, we on a couple of projects we were trying to like lean into this a little heavy, and we started off really well, and then deadlines started creeping in, and little changes coming up here and there, and you kind of fade away from it. One of the other things I found, and we'll talk about it later on, if you have flaky tests, that tends to make you stop writing tests or ignore your tests altogether. So, but there's ways around that too as well. So, why write automated tests? So they ensure your code works the way you expect it to. This can be easily overlooked because you can like, oh, of course it works, you know, that sort of thing. It worked when I wrote it originally, but do you know it still works that way? So unit tests, automated tests can help with that. To protect against regressions, as I just mentioned. Obviously, I didn't practice all that well. So a lot of us may be currently doing manual tests for this. So you're already doing testing. Most of us just do it manually. You make the change, you run the test. I mean, you fire up your application, you see that it works, and you move on. Oh, this is another one I thought was interesting. It can help you find conflicting requirements. So today your user comes in and says, do X, Y, and Z, and then 6 months later they tell you to do something that's in conflict with X, Y, and Z. How do you know that those two things are in conflict? If you had a test for X, Y, and Z, and you try to do A, B, and C, which they're asking for now, and every time you get A, B, and C to work, X, Y, and Z test fails, and you get X, Y, and Z test to pass, and A, B, and C fails. And you can kind of find those conflicting requirements. I thought that was a nice little tidbit in there. And it can help you communicate how things work. So if you have a new developer that's starting, they can look at the test suite and say, okay, well, here's what it's supposed to do. And they can kind of look through that. I've heard this argument a lot of times. I myself have never gone to a test suite to figure out how code works. You can go there maybe to figure out some of the assumptions.
I do this. I totally do this. Like, it's the easiest way to get the code, to see how the code runs. Like, if it's a great way to like get the code to run. So it might not be the place you start. Maybe you start with documentation, but if I want to run the code, the first thing I do is to find a unit test that runs it.
See, so there's another verification of that. Like I like it for seeing how the code is structured. So it's like if I'm looking at a particular thing, like what are all the calls that have to happen, and you can see it with raw data as you kind of step through it or something like that. But I've never actually looked at it as far as how things actually. Well, I guess that is how things work. Never mind. All right. So this is the big one. This is what we were talking about online. So this is where the controversy steps in. So what are the kinds of automated tests? And the pyramid kind of gives you some clues to that. No one wants to bite. All right. So you have unit tests, integration tests, and generally speaking, UI or acceptance or end-to-end tests. And those are what kind of make up the pyramid. They call it the testing pyramid. Anyone want to take a guess at which one's which?
I'm really hoping unit tests are the bottom.
Yeah, Joe. Huh? Yep. Yeah, that's how it usually lays out when you see it somewhere. You have unit tests is supposed to be the bulk of your tests, and then integration tests are a little bit, on top of that, and then end-to-end tests are above that. I say that's not right, but here's where the controversy kicks in. So there are other types of tests too that we don't really talk about that much: property tests, fudge testing, load testing, performance tests. We're not going to talk about any of those things because they didn't make it into the presentation, but they all exist. And there's other types of tests too as well. All right, so here's another way to view the test. This is my opinion after working with testing for a little while in those couple projects. I don't think that pyramid structure is actually, well, let me just say this. So I think the differentiation is between fast tests, slower tests, and slow tests, right? So you want most of your tests to be fast tests. You want less of your tests to be slow. You want your tests to be as fast as possible. And the reason for that is if you have slow tests, you're not going to run your tests. You're not going to wait for them to finish. You're just not going to, it's not going to provide you much value. Before, this can kind of correlate to fast tests being unit tests, or, in the middle tests being integration tests because they take a little bit longer to run, and then end-to-end tests taking the longest time to run. But I think those boundaries, as we go through it, you'll see, I think those boundaries between unit tests and integration tests are artificial. And they don't necessarily, a lot of people point back to some testing principles, like isolating your tests and stuff like that. And I think if you look back at the original, what they were talking about then and what we use now, they said that your test should be repeatable and isolated. They don't say your test should be one function or one class. And there's reasons why I don't think after, when I started off, we started writing tests, we were very much in that one function, one class sort of testing. And it led to flaky tests, and it led to things that will make you not want to test later on. Or it led to some bad design choices as well. All right, so like it's mentioned, it determines how often you run your tests or when you run your tests. Like, so if you have really slow tests, you're not likely to run your tests locally. You probably just wait for it to run in CI or something like that, and then you end up architecting out a whole solution, and then you get to run your tests and things are broken. And now you have to go figure all that stuff back out again. All right, so Christine mentioned this before. So there's multiple types of testing paradigms. You have TDD, BDD, TND. Anyone know what these mean? Let's take a stab at it.
Test-driven.
Yeah, that's TDD. Yeah, any other ones? All right, we'll get to all of them. Um, I think some of them are interesting. So TDD, start there. Test-driven development. So in this case, you write your test first before you write an implementation. Usually you follow this pattern, the red-green refactor pattern. So you say you write a test that's failing. You write the very simplest solution to make that test pass, and then you refactor it to take in other use cases, hoping to keep that test green. Yep.
So I have a question for people. So nominally, my group did test-driven development, or we were told to do test-driven development years ago. I don't think I've ever done this perfectly. Usually I write my tests and my code sort of simultaneously. And, the tests get more complicated as the code gets more complicated. But I feel like if I tried to write the tests first, I would end up being driven to a particular design, which I might find doesn't quite work very well once I actually get in the weeds of coding it. So I personally find this very difficult to do, even though I love basically at any given moment having tests that will run through my code. I don't know if that's what other people have found trying to do this.
I think you hit the nail right on the head there. Like, that's exactly what I mentioned earlier about the testing, and it drives your design to a particular place that you may not want it to go. It's great for your tests, but maybe not great for your application in the long run as a whole, or performance and for other things like that. It is useful because you know that your code works. But I also will argue, depending on what level you're doing it may cause other problems, and we'll talk about that later. But yeah, so usually you have this red-green refactor pattern. What's nice about this too is that you can stop at a certain point and know your code is working. Working with air quotes, right? Yep, said that already. All right, so
I think it's a little bit weird also, this idea that you write the simplest code to make the test pass, because if all your test does is call the function and check that the result is whatever you want, right? Then you can just return that result regardless of what the inputs to the function are, and boom, you're done. So it seems to encourage you to not create a generic solution.
Gotcha. So you mentioned this, and that's perfect, because that is literally what you're supposed to do. If I'm writing an add function, I think I have that example later on. You say, I send in 2 and 2, and I expect 4 to come back. So when you write that test, you don't even have the add function, so it's just going to fail automatically. So you create the add function and you have it return 4, and that test passed. So you've gone from red to green, and now you add another test to say 2 plus 3, and it's going to return 4. So now you have to get that test to pass while keeping the other test passing. And that's where you end up refactoring, right? And so keeping both tests green. And so you do end up with just enough code. So I am guilty of over-engineering a lot of solutions, and this helps you stay focused. Like, if it's not one of the cases that you can think of, then you don't necessarily build it in until you need it. And if you need it, then you write the test case for it, and that one has to pass while all the other ones are still passing. So it does help a little bit, and you do end up with another thing inside it. You end up with high test coverage, which is okay. You end up with smaller, more composable code, which is in itself good, right? Here's the risk. So your code gets optimized for testing, but not for the end user, right? Which is not always good. You end up testing the implementation versus the system requirements. And I think this is the big one, right? Because now I'm testing very minute ways that I implemented the code. Like, it's almost like the test code is reproducing the code in reverse, right? And so what ends up happening is, if you want to go and refactor your code, depending on how you wrote your tests, a bunch of tests are just going to start failing, right? Because you're testing the implementation, not the requirements, right? So this is, I think, a big risk if you do it this way. You can still do it this way, but you have to be cognizant that you're testing requirements, not implementation, right? All right, so BDD. Yeah, we already said that. So BDD is behavior-driven development. This is kind of the approach of let's test the requirements, not necessarily the implementation, but the requirements. I think this is a little bit better than you can do this and TDD at the same time, but you're just kind of saying you're extracting your requirements or your test cases higher up the stack. So this is almost synonymous with now we're doing integration testing, right? Emerge from TDD with some additional concepts, domain-driven design, that sort of thing. Sometimes the test can be written in English. There's, I think, Cucumber and I can't remember the terms. There's a couple of things where you can literally have the test in English and it runs your test, which is useful because now it allows the business and development team to speak the same language so that the business people can go in and actually write tests. And it's really interesting when you see it working. So they can write up test cases using given phrases, usually it's in that given, when, then sort of format. So you say given I want to add 2 numbers, when the numbers are 2 and 2, then the output should be 4. And they can write new test cases that way. And you basically build a builder pattern to build up what the actual code would be for that underneath the covers. So that's pretty useful. It tests at a higher level of abstraction, which I think is also useful. All right, so here's another one. I didn't have it in my list up there, but TAD, which we did after we started, getting really annoyed with TDD, which is like test after development. So especially this is really useful too if you're doing exploratory coding. Like you don't know what you're building yet, so it's hard to do TDD because you don't really know. You're just kind of throwing things at the wall and seeing what makes sense. So this one is good, but there are some risks with this. You have to make sure that you're actually your tests are testing what you think you're testing. It's really easy to write a test after you wrote the code, and it's not actually verifying that the code works, right? A good way of doing this, if you write tests after you do the development, then write the test, make sure it passed, change the code, and it should fail. If it does not fail, then it's not testing what you think it's testing, all right? This requires some diligence, right? Because you can oh, my test passed, and you're off to the races, but not realizing that it's not even testing the code you think it's testing. Right? And the other one too, you may never actually get back to writing the test because the code's working. So let's keep moving. All right, so here's another one, TND.
Oh, sorry, can I just, I think I would like to add for TAD that the other problem is that you can write your code in such a way that it is testable, and you can write your code in such a way that it is not testable. Mm-hmm. If you only write tests at the end of all development, I can practically guarantee that writing the tests is going to be either impossible or extraordinarily painful. So yep. That to me is one of the biggest risks, that you end up structuring your code in such a way that it's very difficult to isolate pieces of it to write tests against.
Yeah, 100% agree. So here's the thing with tests. The more you write tests, the more you will write your code in a way that's testable. So even if your piece of code doesn't have, if you're used to writing tests, even if you write some code that does not have tests, chances are you're more likely to write that code in a testable way because you've just been trained to do it that way. You've been trained to structure it that way. If you're doing tests after development, I would recommend you don't do large swaths of code before writing the test. Like you don't want to build the whole application and then go back and try to write tests for it. Maybe like little modules or little sections or whatever. Say, okay, it's working. Now let me go back and verify it. And two, I don't think you have to write. Here's the thing that people get into with TDD a lot. They write tests for stuff that don't need to be tested. If you have a property and it's literally just giving you back the internal variable, right? Does that need a test? Probably not. You know what I mean? But people are looking at their test coverage and like, I got to write more tests, more to get my coverage numbers up. But it doesn't mean anything. And it ends up bloating your test suite, which means that your tests run slower, which means you're less likely to run your test, which means it defeats the whole purpose. So test what's important. Complex code, critical code, that sort of thing. those are things I would test.
I have to say, I think it's interesting. I know that some projects at Goddard require 100% test code or test coverage, and
oh boy,
I understand like where they're coming from, but I think practically speaking, if you're not writing flight software, that 100% code coverage, I think you're right, just encourages people to write tests that test every line, but you can have 100% code coverage and still not be writing good tests.
Oh yeah. I was about to say this. If you open up their test suite, if no one's verifying what the tests actually are, I guarantee you there are tests in there that just like don't do anything. Literally don't do anything. They just exercise the line of code and throw away the what do you call that? So you arrange or act assert. So the assert. They'll have a test in there, runs the code, but doesn't actually assert on anything. And that will boost your coverage. It will say, yes, you wrote a test against this line of code, right? It's not. And just because you exercise that line of code does not mean you've tested that line of code in every scenario, right? So there is multiple caveats there to that whole.
To be fair, I think that sometimes there is value to like a test that basically says this didn't crash. Like if you look at, there's a Python tool called Hypothesis, which does testing, is it called stochastic testing? I can't remember. Like basically you give it properties. You say like this input is an integer, this input is a string, and then it just, generates test cases for you and runs them. And actually the guy who wrote Hypothesis said that the number one thing he uses that for is like, this should not crash. Like you should be able to hand it any kind of ridiculous input and it won't crash. So sometimes if used judiciously, having a test where you're not actually asserting that it did exactly what you expected, but just that like it didn't misbehave is not horrible.
Which is testing that is doing what you expected to do, is handling the edge cases appropriately. And that's one of the test types that we mentioned earlier with the fuzz testing or property-based testing as well, which is, I think is useful. Like I remember when I was in school many, many moons ago, Dr. Hugh, one of my favorite professors, she said, if you're going to be writing the code that's operating the plane that I'm flying on, it needs to not crash when someone does something unexpected, and so I think that's very valid. Like you need to guard against bad input, and you can do that with test cases as well, which is also another valid use for tests. All right, so last one is TND, test never development. It's not recommended, but it does happen. But you do want to write tests. All right, so mocks and stubs. Anyone know what these are?
Mocks I've definitely used. Very useful. Can end up writing more you can end up writing mock code that looks exactly like full code somewhere. You're kind of duplicating stuff that already exists. So used judiciously, very useful.
Yep. So this was also part of the controversy that was online. And you guys can go back and read it. Maybe I'll link back to it. So mocks and stubs, what are they? So stubs are basically code that you write as stand-ins for the real implementation. So let's say I'm testing my math class, then I write another math class for my test case and like stub out the things that I don't need, right? That's useful in some cases. Mocks are generally generated by the test framework. They're pretty much the same thing, but there's like, hey, the framework saying, whenever you get a call to this function or whatever, I want you to do this thing or return this output and that sort of thing. So that's the difference kind of between mocks and stubs. Kind of test on. Oh yeah, so there's another thing too. You can test that a mock was actually called. So let's say you're actually seeing whether or not your test case is saying, when I do this thing, is this particular line of code or this particular function called? And if you put it in a mock, then you say, yes, it was called. How many times was it called? Whether or not it's called once or 1,000 times, if that's important for your test case. So that's also a good use case for mocks. here's where the controversy comes in, if I remember correctly, maybe. I say you should avoid using mocks and stubs. Anyone want to argue? Go.
Okay, I'm totally going to argue with you here.
Go.
Okay, so I'm going to give you my use case, all right?
Mm-hmm.
I'm writing code. I'm writing what's called a Lambda function in AWS, Amazon Web Services. This Lambda function needs to go to a queue, grab something off the queue, do something with it, and stick it on another queue. Mm-hmm. I use Moto, which simulates a queue. So it allows me to stick a thing on a queue, call the Lambda code, check the other mock queue, and make sure that the result that I needed is there. Like, how else do I test this when the code itself is calling a library where I would prefer that it not actually call the live system?
Yes, you are using it appropriately. So this is why I say don't.
I'm touched, Andre. Thank you.
Yeah. So no, this is why I say avoid and not say don't do it. There are cases where if you're going to reach outside of your code base, use a mock, right? Or use a stub, because you don't want you're testing the missile launch. You don't want to launch the missile every time your test runs. you want a stub for that, or a mock, right? Here's why I say avoid using it. Sometimes people say if I'm writing a function and it calls another class within my own code base, they'll mock that other class out because they say it needs to it's a unit test, so I'm not supposed to be testing anything outside of my unit. This is why I say don't do that. And I say, well, anyone want to guess as why I would take that stance? Because we started off very much the other way. We mocked all the other things. And it was like, life is great. And then later on, we realized life is not great.
So I think this might get back to I'm now remembering this conversation. Previously, I was not remembering this conversation. So I think we got into an argument over like what was considered a unit test versus what was considered an integration test.
Yep.
I think we have similar definitions of what is unit versus integration. For me, I call it an integration test if it has to go somewhere external. So it might be, for example, my code, but on a server somewhere. Or it might be code that I'm calling locally, but it's not my code. Mm-hmm. And not something that I have a huge amount of control over. But it's usually like, I call it integration if it's calling a URL, basically. And so I feel like if I'm just using a bunch of my own libraries, like I might as well use them in the unit test, because I actually want to know right now if that code has changed and is now breaking something that I'm doing. Like there's no reason to not, because otherwise what is going to happen is that these mock objects you've created are going to drift away from the code, the other piece of code that you also wrote. So you might as well just go ahead and use it unless you have some like super good reason not to.
Yeah, I 105% agree with what Christine said. And this is the lesson learned that we learned the hard way. It's like we end up, if you mock out a lot of things that are just your own internal code, right? Not reaching out to some external source or whatever, they end up drifting apart. Instead of testing your implementation, now you're testing your mock. Like my mock works. That didn't tell you anything. It's like that picture, if you ever seen it, where it's like my unit tests work, and they have the faucet over here and the sink like somewhere totally different. You know what I mean? Like they tested them individually, but like together they don't work. Right? They've drifted apart. And so this is why I say, and I think that's why I mentioned earlier that difference between unit tests and integration tests is an artificial boundary that we put up. It means different things to different people. Like at the end of the day, it's like fast tests versus slow tests that reach outside of your environment, or tests that are all in your environment, that sort of thing. Thinking those are the only barriers I think that really matter. Whereas, like I said, some people were like, hey, nope, you should only test a function and only a function. You should mock all the things. I think there's an actual term for that too. It's like Marxism or something like that. There's an actual, there's a split in the testing environment where you're either on one side or you're on the other side. It's interesting. So yeah, we started off, like I said, stubs and mocks a lot, and then we realized we were end up testing things will work in our unit tests, and when we deployed them, they did not work. because we weren't testing, depending on your term, we weren't testing the whole stack together, all the pieces together. So avoid mocks and stubs if you can. That's my reason for saying that. All right, so they ensure that they're not out of date integration tests. All right, so here's another thing too. Aim for pure functions if possible. They are just easier to test, right? A pure function basically means that all the inputs are given to it. It doesn't reach outside of itself and change something, right? So that way, every time you run it, it's always going to come back with the same result. It's not going to change it's not going to change the state of the world, right? We mentioned this too before. Test the seams. I think this is that the picture? Let's see. Yeah, here it is. This is another funny one. Yeah. I don't know if you guys can see that. So this is an integration test without, unit test without integration test, right? So the blower works, the trash can works, blower on top of the trash can does not work, right? So I thought that was funny. How do I get back? I totally messed up now.
I will say this, that the one difficulty with doing a lot of pure functions, because I'm completely with you on this, and my functions have become more and more this direction the longer I code. The only issue is then you run into functions that take like 50 gajillion inputs.
Yeah.
So sometimes like my code, whatever, says like, do you really want this function to have, 7 inputs? It's like, yes, I'm sorry, but I do.
Yeah. So that time with that, we ran into some of the same things as well. Couple ways around that, like you can do like create an object if that, and have, it's kind of like, it's still the same thing. Yeah, you pass the object in. Another thing could be like currying, where you pass in, because not every bit of that function needs all those parameters at the same time. So you can split them into smaller functions that kind of curry on to each other, right? It's like the output of this function then goes into the next function, which goes into the next function. And each part does the part that it needs to do. And that's been useful as well for solving that big, parameter thing. Usually if you have a lot of parameters, it means the function is doing a lot of things, which probably can be split out into doing separate things. Now, the caveat to this is that you have to balance this against performance, right? Because sometimes you're putting all those things in because it's more performant to do it that way. And you just have to make the judgment call at the end of the day. Sometimes pretty and performant don't go together. So I tend to err on the side of pretty as far as readability until performance becomes an issue, and then refactor with a comment above it saying, I know this is ugly. It's done that way for performance. Don't touch it. That's what.
But I thought you didn't like comments, Andre.
I don't like comments. I don't hate them. I'm not like starkly against them. I hate comments that are there like, stating the obvious. You know what I mean? Like the comments that are there like, there be dragons. I know you want to go here and slay these dragons, but they will kill you.
I hate comments that are no longer correct.
That's why I don't like comments. I have years and years, Mike knows it because he's worked in the same code base, where like the comments were there and they are no longer accurate because they've changed. The code's been changed multiple times and the comments have not. So I don't know which one's lying, the comment or the code. I don't know. But yeah, I'm a favor of comments that say the why and not the exactly what sort of thing. But yeah. Oh yeah, so we talked about here, if you're reaching out to your database and that sort of thing, those are just going to be slow tests because you have to build that whole environment up, run your test, and tear it all down. That's going to be slow. Third-party APIs, like Christine mentioned earlier, these are the ones you want to mock, but you also want to just make sure that you keep those mocks up to date. There is I think in Ruby, they have this thing called like VCR. I'm not sure if they have other things like that where it'll basically do that test every so often. So let's say you had third-party API, and you're running it in your test, then maybe every 200 times your test runs, it actually hits the real API, records the results, and then uses that for the next 199 tests, which is pretty useful because you know when your API is broken, that integration is broken, which I thought was pretty cool.
Also awesome is like somebody else is creating the mock library for you. That is completely awesome. Like, oh, here it is. Let me just use it, and they're keeping it up to date.
Oh yeah, yeah. That I've never run into that situation, but that would be sweet as long as they keep it up. So then you'd have to keep your reference up to date as well.
So you do have to make sure, yeah, that you're kind of keeping your packages up to date, but you should kind of be doing that anyway.
Yeah, Turtles all the way down. Sure, I update my node packages all the time. I'm a good steward. All right, so I went to test. All right, so the React team was really interesting. So they rewrote React completely, and they were able to do that because their tests are behavior tests and not implementation tests. So all the code changed, but none of us were broken that use React because all their tests were behavioral tests. So they tested from the outside in all the behavior that is the requirements, and that freed them up to re-engineer freely the internals of their library without breaking anyone that uses their library. I am a big fan of doing it this way. There are some techniques. I think there's another talk that I gave about how you can build tests in this way and not die and not kill yourself. You know what I mean? Using a builder pattern, which is pretty useful. Like we refactored a lot of the tests that we wrote internally to this builder pattern, so that you can build the state of the world and then run the tests really easily. And you can kind of test everything from the outside looking in. Really useful. And then the reason why we did that, as well as some of the things we moved away from TDD and some of those other things, because now we're testing the behavior instead of the implementation. So when we want to refactor things to make them go faster, or we want to refactor things for whatever reason, maybe to make it more readable, we don't have to rewrite our tests every time we do that refactoring. Any questions on that one? Because I think that's a huge one. This is one of my biggest lessons learned in writing tests. All right. So this is an example, I guess, var calculator. Is that spelled right? I don't know. Multiply, and you expect, multiply and you give it 3 and 3, and you expect the result to be 9. So that's external, right? Another way you can do it is basically looking at the add function, like call the add function this many times or something crazy like that, and that would be testing the implementation. So I can change that out. Actually, I guess my point was that the multiply function is using the add function internal, but I'm not testing the add function because it's private. So if I want to go refactor that later on, I can do that without having to rewrite or change around how my multiply function work, my multiply test, whatever the case may be. So in general, my recommendation is don't test private functions or private classes directly. They're private for a reason. Leave them alone. Test the public API. All right. Oh, I did have it in here. So avoiding flaky tests using a testing DSL. Anyone know what a DSL is? Did I put it up there?
Specific language.
Yeah. So you can create your own domain-specific language for your test environment, and that helps you to write tests that are very easily readable. Is that all right? I don't know. That reads really easily, but also is pretty powerful, right? So I like the arrange act assert pattern. Create a DSL. I have another talk that goes more in detail on some of these things, in which case we build a system under test, which is basically our universe at the time. And you pass in just the things that you need to run your test. It'll supply everything else to make the universe whole and real. And then you run your tests. Another thing that was interesting too, and maybe people don't do this anymore or do this as much as they should, is your code, your unit tests, your integration tests, your automation tests are code, so they should be treated as code. If the code is not useful anymore, delete it. It's okay to delete tests that are no longer needed. You know what I mean? it's okay to go back and refactor tests and groom them because they are code. They do bit rot like everything else, right? Again, don't test internal implementations. Avoid pixel matching tests on UI that's still in flux. So if your UI is settled down, then you can do that whole, this picture is supposed to look like that picture. And I want to make sure that's the case. They have snapshot testing with some libraries now, which is pretty useful. But you don't want to do that when you're like still changing your UI drastically, because then those tests are just going to constantly come up as failed. And that's just going to be, you know, broken window syndrome. Like, yeah, it's okay, the test is supposed to pass. I mean, they're going to fail, just pass the build, merge a commit anyway. And then other tests creep in that are failing. That's not good. Run your tests in CI as well. Very, very important. We've broken all of our CI when we moved everything to one big repo or one big project. We have to get those back working. So yeah, tests are no good unless they are executed and tracked. So it doesn't matter how many tests you have or how awesome they are. If they're not run, then they are totally, utterly useless. Make sure your tests. Oh yeah, make your tests a requirement for merging your code. So this is very important for those cases where it's an emergency. We just gotta get this fixed. We gotta get this bug fixed into production. We're gonna, you know, bypass all these safeguards. Like, no, don't do that. You just create more emergencies. You can have a fast track that it doesn't go through, you know, all the same path, right? But it should run your tests. The tests are there to keep you safe. I can't tell you how many times we had this one piece of code that was related to our security system, which was very complex. I refactored it, and in my local cases, it all worked perfectly. And it's like, man, this is 4 times faster. This is beautiful. And I pushed it, and it ran in CI and ran all the tests, not just the local ones I was running. And I had broken, I think there were like 700 tests. There were like 80 tests that failed. I'm like, yep, don't push that. don't merge it. Let me go back and fix this. You know, it was 2 times faster later, but all the tests worked. That was a win. Right? So yeah, tests are there. You got to make sure they run. I think that was it. That's the last slide. Yeah, so that's the controversy. The controversy was around, the biggest thing was around mocking and test stubs and integration versus unit testing and what those mean. But I think a bigger lesson is that testing your public API, don't test your implementation. You can, and it'll work for a little while until you get to a longer, more stable state where you're refactoring things, and all of a sudden your tests are getting in your way. It's like, I refactored this thing, and now all the tests are pointing specifically to this implementation that's no longer there, and they all fail. Not useful. That's not a useful test at all. It doesn't tell you anything other than you wrote the code, and you know the code, so you reproduce it in your test, and it does the same thing. Testing the public API is what you want to do. Using that builder pattern or something similar makes that doable. You don't have that, then it's kind of hard. You got to build up all that use cases to test it from the outside in. Okay, that's it. Any questions? All right, so next time, I think we might be doing the Kubernetes one. I'm gonna post a link. There's a tutorial that I'm taking online, which is really, it's not even a tutorial. It's just a bunch of slides with some instructions. They've been pretty good though so far. So I'll post it, and other people can review it. And I'll just basically be talking through some of those things and some lessons learned. And hopefully some other people that are doing Kubernetes will come in and say, hey, yes, no, maybe so. Cool. Thanks everybody for coming out, despite not having any pizza. Thanks, Christine, as always, for your presentation. Very nicely done. Oh.
Questions if anyone comes back for no pizza next time.
Yeah, that's gonna be the question. That's gonna be the big question. I don't know. I mean, when we first started doing this, I would buy the pizza, and so I realized, like, why am I like one other person did it one time and they got the company to pay for the pizza. I'm like, I didn't have to pay for this the whole time. So we'll see. We'll work something out though. All right, everybody, we're signing off. Thanks, everybody.
Bye.
Bye. How do I? Let's see.
I was looking at some code, had a comment up top saying, this is correct